subintervals. And now we have to choose, we want the leftmost point, the rightmost point, or the midpoint. Which one would you like to use?
The right.
Okay, very good. So we want A4 right, or right 4. Doesn't matter how you want to write it. As long as you understand what it is, I'm fine. Good. So the interval is 0 to pi over 6. So delta x will be pi over 6 divided by 4, which will be pi divided by 24. So this is pi over 24, and so on and so forth. So the integral from 0 to pi over 6 from sine squared dx will be pi over 24, and we decided to use the rightmost point. So these are the rightmost points. Okay, so pi over 6 divided by 2 is pi over 12, and this divided by 2 is pi over 24. Correct. And then pi over 12 plus pi over 24 plus pi over 24. So it's 3 pi over 24. It's pi over 8. Okay. So this is sine squared of pi over 24 plus sine squared of pi over 12 plus sine squared of pi over 8 plus sine squared of pi over 6. If it had said the left, I would have used 1, 2, 3, 4. If it had said the middle, I would have had some more calculations to do. Okay. So now, make sure that the mode is in radian mode. Is it? It is. So in parentheses, pi divided by 24. Parentheses again. So I will put everything in parentheses again. So sine pi divided by 24, close the parenthesis and square, plus parenthesis, sine of pi divided by 12, close, squared, plus, open, sine of pi divided by 8, close, squared, plus, open, sine, pi over 6, I don't need that. I know it's 1/2, squared is 1/4. Anyway, I wrote it now. So, pi divided by 6, close, squared, close the parenthesis, done. Approximately 0.06289. Good. Anything else? So we did that, we did the limit of the Riemann sum, we did this, we did the indefinite integrals unless you want to. Properties of definite integrals if you want to. Antiderivatives, we'll be doing them all the time, but we can choose. Fundamental theorem of calculus, in which we are only asked to find G prime. You cannot evaluate this. You can only be asked to find G prime for something like this. And properties. Oh! Sorry. Problem 3 on 5.5. WebAssign. Okay, let me share my screen. Okay, so we have the integral from x to the 5th sine x to the 6th dx. Is this the one? Doesn't look like it, is it? Is this what you meant?
Yeah, it was on mine. I think it says x to the 7 and then x to the 8th.
I corrected it. Done. Very good. Okay, perfect. So of course I don't like this inside of sine. So I'm going to say let u be x to the 8th as long as du is in the problem. Yes, it is. This and this. It's missing an 8. Who cares? So then from here we have 1 over 8 in front. 8 x to the 7th and dx will be du. And what is left is sine u. And the answer would be, since cosine prime, this has to be negative cosine prime to be sine, right? So negative cosine u divided by 8 plus a constant c. And we have to go back and replace u by x to the 8th. So negative cosine x to the 8th divided by 8 plus a constant c. But I don't think that this is what you meant. Is this what you meant?
For whatever reason, when I had to enter it, I needed the c to the 7th power for some reason before I take it.
But that's very strange.
Maybe it's just a glitch.
It cannot be. There is no need for that. Okay. Good. Next question. Anything else that you encountered? Anything else that you want to look at? Anything else?
I have a question about property.
Yeah. Properties, very good. Yes, very good. So
It's not really a question, but just about how to answer, and I'll have to respond to a
very good question, but I don't have a recipe for all situations. I wish.
I just want to know how are we supposed to answer questions where we have to use a property of, what is it, like odd functions?
Oh,
So
just
like when
I had one here. I thought that I just wrote solutions today.
I thought it was 72, I think, in the 5.5 homework.
The previous one.
Yeah, the one that's due today, number 72 and 5.5.
72 and 5.5. Yes, that's all. Odd function and symmetric interval.
Oh, that's all we have to write?
Yeah,
Okay. Alright, thank you.
thank you. Anything else? Other questions? Anything else? Anything else you would like to go back to? And
I got another one from
yes,
WebDesign.
ready?
It was question 5.2 and number 6.
You wanna? Do I need to share? Do I need to? Can you give it to me, or do I need to open the book?
I don't have
That's okay.
written on my paper.
No worries, no worries. Let's go. So we said 5.2 and number 6. Use the form of the definition of the integral given in this to evaluate the integral. Okay, so the integral from 1 to 5, from 3x squared plus 8x. Do you want to change anything?
Hold on, I'm taking a look.
Do you want to change the constants? Oh yeah.
I see. Never mind. Hold on.
But you may want to change the
Okay,
constants.
The constants on mine were 6 and 7
Okay,
instead of 3 and 8.
good. Changed. Good. So then we have to write 6x to the third over 3 plus 7x squared over 2 and from 1 to 5. We plug in 5, so I simplify, so this is 2. 5 to the third is 125 plus 7 or 7 halves times 25, and now minus, when I plug in 1, so I get minus 2 and minus 7 halves. So this is 250. This is
This particular problem was asking for it to be done a certain way.
with areas maybe, or rectangles, or
It says use the form of the definition of the integral in
as the limit of the Riemann sum,
in a specific theorem.
as the limit of the Riemann sum maybe.
Maybe. I
If
can't have more than one window open while I'm talking in the Zoom, so it's
right, so if we want to do this with the limit of the Riemann sum, we can, but we have to do this. For this function, we can, because we have all the.
asking for the Riemann sum.
Let me share my screen. Yeah.
That's what I wanted.
Yeah. So you can either use the integral, the definite integral on the left, or the limit of the Riemann sum on the right. It's up to you which one you want. Now, when it says the limit of the Riemann sum, then you have no choice. But in this case, you can use either the left or the right, as long as you determine the integral. Is that okay?
I think I was getting caught up on trying to figure out what number n was. Is that ever anything specific, or is it just always n?
It's n because it's the number of subintervals. So see here, the number of subintervals is the one that goes to infinity. Very good question. Let me stop sharing. On the previous example, n is 4. We're specifically told to use 4 subintervals. But if you want to determine exact area, that you cannot use 4 or 6 or 8, you have to use n from the first subinterval till the nth subinterval, and furthermore, n, the number of subintervals, goes to infinity.
Okay, so this is an application of a limit sort of problem.
Yes,
Okay.
because we want the exact. But this is not exact. This is an approximation using 4 subintervals. Is that better?
Yeah, I think I just need to know that instead of looking for a specific number for n, that it needs to
No, n is the number of subintervals. That's why the width of each subinterval is the width of the interval divided by n, their number. That's why the width of all of them is 6 over n. And to make sure that there is no error, n goes to infinity. Is that okay?
Oops, it's a little bit. I'm going to take some time to review the other example we did. Really nail it down.
So what do I have here? 25 times 7. Okay. And then minus 7. I have 168 divided by 2. And I can divide by 2. 84. So this and then this with this is 84. And minus 2. So 250... 250 plus 82. So what do I get? Did you get 332?
Oh, I got a whole bunch of like eraser marks and stuff on my paper.
So so what was your number?
I didn't finish this problem.
Oh, okay. Just double check. I got 332. So it was 2 times 125. That's, yes, that's 250. I calculated 7 times 25, yes, and I subtracted 7. And then I divided by 2 because that's the denominator for those two. I got 84 minus 2, so that's 82. So 250 plus 82. And I got 332. Let me know.